So today I'm going to give a demo of my RC servos. It's the giant RC servos. I got the two new ones off Amazon. It's the like ASMC-04A and the ASMC-04B, and I've got one of the random ones from China that I bought. They basically look the same. The new ones have a blue board instead of a red board. But I'll show you in a second here what they're actually doing. So let me so here's my 3 RC servos bolted to a bracket, and I'll hook it up to the battery. And you can see they moved as soon as I turned it on to match whatever the servo tester is doing. You can still hear me, can't you?
Yep.
Okay, so what I'll do is I'll just turn the knob here, and for the layout, the one on this side, this says, you probably can't read that, but it says 04A. The one that says 04B, and this one, the part number is 4 Chinese characters, so I didn't write those on here because I don't recognize Chinese. I could have printed it out and taped it on there, but I didn't do that. So when I run this, you can see as I turn the knob, they're all hooked in parallel. And for some reason, the center one doesn't seem to have as much range as the other two do. And I thought they should, but they don't seem to. And then, so the one on the right is the fast one, and the one on the left is the slow one. So if I do this, you can see that the one on the right is pretty snappy. It goes to where I tell it. And the one in the center is kind of, I think, in between the two as far as the speed on it. And you notice the one in the middle is not really working all that well either. So if I start turning here slowly, you can see the outside ones are turning, but the middle one's not. And then the middle one catches up. And that's why I was complaining about these. I don't like the way it was working. And I bought these new ones, and they seem to work quite well. So if you actually pick up the servo and hold it in your hand and turn the knob, you can feel the servo, the new ones, you can feel the motor thumping as it's trying to track, as it goes through A to D steps. So I'm pretty happy with these new ones. And I just wanted to show that they do work, and see as I turn it just slightly, they seem to track really well. And
how's the torque between the 3?
So the slow one of the new ones is 180 kilograms per centimeter, which is what everybody's been assuming these things are. And the fast one is 110 kilograms per centimeter, but it's 4 times faster according to the numbers. So, if you can whip it back and forth real quick like this. So for my steering, I probably want one of the new ones and the fast one. And then I can always slow it down with software, because see if I just move it slowly like this, see the two are tracking, the 2 outside ones are tracking. And until I get really wild like this, then it's a problem. So I don't know, until I actually bolt this on a vehicle and look at my steering to see how it acts, I don't know what it's going to do. So that's so I'm saying that's pretty much the demo for the moment. Any questions before I switch this back?
So just one more time, the one on the right for us, what's that model?
That's the ASMC-04A. So the A and the B is tells you which one you're getting. And those, I think I posted on Slack channel. I'll post in the chat here before we're done, so you can see what that looks like.
Thanks for the demo. That's awesome to see those side by side and the relative performance of them.
And it's just simply all 3 of those are the signal wires wired in parallel on all 3 of those. And it just has one of these, one of these little servo testers that I bought on probably Amazon. So basically, just on the servo tester, it's actually got on this end, it's actually got 3 rows of connectors there. And I guess my camera is not going to focus, but it's just got 3 rows of connectors. And since the servos put out 5 volts, I just have one of them wired up with a 3-wire cable to power the tester, and the other 2 I just have the signal wires wired up and running. So that keeps everybody happy. Actually, I got grounds hooked all 3 too, and I would have to look into that to see if that's the appropriate thing to do or not. So let me switch back to the real world here. So that just shows you on a side-by-side basis what the things are doing. And up until just about last week, I didn't realize you can get one that's faster than the original ones that everybody's been playing with. So I ended up ordering one of those, and it looks like, you know, for my steering, that looks like it'll work great. And from my transmission, if I put one of these on the transmission on the lawn tractor, I had it set up, and I had, well, I guess the arm for it is upstairs, but it, you know, if you look at the servo here, the arm on it sticks out to about here. So it's got a big lever arm on the thing. So I only have to turn it like, you know, 20 or 30 degrees to get full travel on the hydrostatic transmission. So even the slow ones should be able to do that and come to a stop in a reasonable amount of time. And on mine, on the Cub Cadets like Al and Matt have, it's got a spring built into the transmission. So when you pull on the lever, you have to pull on it and push against the force of the spring. When you let go, it snaps back to a stopped position. Mine does not have a spring, so I've got the advantage that, you know, I can move it to a position and set it there, and it'll stay. I've never tested that while the engine is running, so it could be that it's going to act a little bit different, but I don't have that extra spring to try to work against. So that's kind of the thoughts on that. So I guess at the moment that's all I have to say about that, other than I was gonna post those part numbers to the chat here. What was their thing? Part numbers. I don't know what else it was. So I think with that, I'm going to say that's all I had for this time. So I'll turn it over to somebody else.
I'm going to jump in quick because I need to leave in about 10 minutes.
Okay.
Brief update. I tried using 2 different PID libraries and couldn't get either of them to work properly. They weren't, I was unable to tune them at all. And I couldn't keep the I couldn't use a timer interrupt because the PWM software library does not have volatile capabilities. So I couldn't access any of that from within the interrupt. So I decided to rewrite my own PID just so I would understand it better. And then again, ran into the fact that I couldn't set the PWM within an interrupt. So I'm going to move all of that PID calculation into the main loop, but only execute it if enough elapsed time is gone and not too much elapsed time is gone. So I can incorporate the timing into the PID calculations. So I'm calculating the proper RPM and thus the proper meters per second. That's where I'm at.
Yeah, I forgot what the whole thing about volatile was, but you know, typically I don't worry about that, and my stuff seems to work. So I can't remember why you have to do that. And you might try it without it just to see what it does, just out of curiosity.
Volatile, the way I understand it, tells the optimizer not to use registers for temporary holding of the values, but to always point directly to the memory location when you're calling it from within a ISR.
Okay.
I mean, Terry, you go ahead, Jeff. I'm sorry.
No, go ahead. No, go ahead, Al.
Well, I was just going to say, I mean, you've probably got a ton of examples to look at as well. I was looked at or tried to make the Arduino, what I'll call the Arduino PID library work, and I didn't really have much success at figuring that out. So I as well have a simple PID in my embedded code. It's in GitHub on the ROS workspace in the embedded code section. I mean, it's written in C, so I don't know what language you're after, but it was written in such a way that it could be the PID for multiple things. But again, it's just if you want another example.
I found a really good write-up and tutorial about how this particular guy has evolved his PID library. And it makes sense how he evolved it and optimized it. So I'm just kind of going to go through his steps, making sure I can duplicate the process. And I'm at the point now of moving it out of the interrupt and into the loop function, I guess.
Yeah, Jeff may not remember it, but I do. I'm quoting him as closely as I can. A PID only needs about 8 lines of code, and he's darn right. So anyway, again, if you want another example, there's one
Okay.
out there on my GitHub stuff that lets me control how often the PID routine is called, and then obviously does the P and the I and the D.
Another thing to
Yeah,
consider there, if you have a timer set up that's running, say 10 times a second or 100 times a second, when the timer fires, just go out and read your encoders and store them somewhere and just set a flag saying, I have new values. So that way, all the code is going to be in your main loop. You're just going through and saying, is the flag set? Is the flag set? It says, yes, it is. It just grabs those values. You run any code you want and then clear the flag. And the next interrupt that happens, it just goes out and reads your encoders again. And that pretty much takes care of all your timing right there. So you're not doing anything fancy. You're just simply going out and saying, grabbing the 2 immediate values from your encoders and store them and set the flag. So that's all you're doing in the interrupt.
Okay.
So basically, then whenever your main loop gets around to it, you just got to make sure that you can get to it fast enough, but you're running a fast processor these days. So that's the way I do my stuff. So I just simply have a thing that says when the timer fires, I go out and read the encoder values and store them, set the flag. I'm trying to remember if there's something else I do at that point. I can't think of anything else I do. And then in the main loop, it says, oh, it's time to update the motor. So it says, take the stored values, which we know what time those happened because it was on the interrupt, and you do all the calculations and then just write to your PWM to control the motor or motors. And then at that point, so the actual writing to the motors, the PWM value isn't at a constant rate, but I don't think it has to be. The biggest trick is reading your 2 encoder values, I think, is the bottom line.
Okay.
Of that.
And in the example that I've got out of GitHub, you'll see that. I mean, I probably heard Jeff suggest that sometime before, and in my main loop, I've probably got 5 different functions that are called, and whether it's getting the sensor data or displaying the OLED or doing the PID, each one of those has a separate hertz that I've set. I probably on the PID though, I've probably got that as running as fast as I can, but writing to the steering control motor, I don't know, 5 times a second. I've forgotten. And I would pull it up. It's just I could have barely get logged into Zoom here on my phone. I just don't know how to pull it up and share on the screen. But
Okay.
Direct message me if you can't find the embedded code out on GitHub.
Okay. Well, based on that, I am going to have to bow out now, but I appreciate it, and I will look for the video posted whenever Jeff gets to it to see what else you guys discuss. Bye.
Okay.
See you next week.
Okay. See you later.
My update is out on GitHub. You'll see that I put a couple of files. One is what I call a vehicle dimension helper file, where last time I was trying to get the speed up on my machine in a virtual in Gazebo, and so I put that spreadsheet together to take all the dimensions and to create sort of helper statements for origin and, more importantly, the vehicle dimension related statements. And I've made some progress in getting it to go faster left to right. But on the y-axis, say going from 0 to 10 on the y-axis is slower. And I have the hypothesis that it's computational related. And at the moment, the footprint type that I have in my URDF is a polygon. And in some of the documentation and tutorials, it says that's the most computational intensive. And so I'm trying to change to a line type, which says it's less computational, but I'm struggling to find in any documentation of it about actually how to organize the vertices for the line type. In Matt's example, it is wheelbase set to 0.4 for some reason, and I'm trying to wrestle with exactly what's the syntax of how to set up the vertices for a line type, hoping that will speed it up. But bottom line is, there's what I think is an interesting spreadsheet out on GitHub to help take all the dimensions and calculate the settings. And I'm still in the middle of trying to get my settings right and the speed up, and wondering if I've got a computational problem. So that's where I'm at.
What was that? What were those files called? I'll put it in the chat before we're done here. I'll put a direct link to it if I can track those down. So I know it's out on your GitHub, but what were the files called, or what section is it under?
It's in the support files, and it has vehicle dimensions in the name.
Okay. Yeah, I'll try to track that down. Another point, the two things you said. You said something about X values are different than Y values. What was that you're talking about?
The performance of the tractor going left to right, it gets up to 0.84 meters per second, 0.88 meters per second when I have, max velocity set at 1.8. But when it's going, I say north and south, on the y-axis, it'll only get up to like 0.4 meters per second.
Okay. And what was the other thing? Oh, you said something about on Matt's stuff. He had the wheelbase set to 0.4. Do you remember, was that for his simulator stuff, or was that his real physical lawn tractor, or do you recall what that was?
I don't remember if he had two URDFs. It's in the car-like Seb Planner settings file. He had wheelbase in there at 0.4. And in addition to that, and again, I wish I could pull it up and show you on the screen, there is a footprint type parameter in, I think, that car-like settings file. And he had line type, and he had 0000 as the first point, and -4 or -0.4, comma 00 as the second point in the vertice for a line type. And I don't understand why that would be, because I thought I was describing as a square, and the rear axle, the center of the rear axle would be 00. So it all just, I think what I was going to do is pull up RViz, put in those parameters, and try to visualize it in RViz, and try to muck around with the visualization to see exactly how RViz is displaying it, see if that would help me debug what's the right way to define the line type.
I think if you use polygon, you actually draw a rectangle around the entire area of your vehicle. But if you use line type, I think you just run a single point from the back to a single point in the front, and then you rely on the, when they say inflation ratio, inflation area. So it just simply expands that line out by whatever the inflation is. So just a single line then becomes a really fat line. And then from your point on the front to the, say, if you put the point on base link in the back, then as it does the inflation, that just creates a you know, like a curve sticking out the back. And then on the front, you just put it, you know, I maybe put the point between your two front wheels. And again, the inflation will expand that out. So you have a thing that looks like a pill shape, I guess I will say. But when you're done with that, I think that's how the line type works.
Awesome. Thanks for that. That's really helpful.
And when they say that the polygon is much more intensive or more intensive, I think if you just draw a rectangular polygon, I don't think that's going to set you back any by doing that. You know, if you put a really fancy one, you've got a vehicle and you define all the little pieces on it, then it is going to take more processing power to do that. But I hadn't even thought about that one type over the other might be a problem. So, but that's just some random thoughts, not having looked at that for, you know, years. So that's what I remember about it.
Yeah, if you happen to pull up the spreadsheet, you can see how I calculated that to see if it's right. But yeah, if that line type is base link and then just a point X out based on wheelbase, that'll be pretty easy.
Yeah, and you don't have to go all the way, say, to the front point of your vehicle, because then the inflation, when you put the inflation in, that is going to expand it out anyway. So if you do go all the way to, say, to the front of your front tires, and then when it puts the inflation, it's going to stick out quite a ways. But if you just put, like, say, a point between your two front wheels, just like in the back where you have base link between the two back wheels, in the front, just pick a point between the two front wheels, and you could probably use those 2 points to create that line, and that would probably work out.
Cool.
And let's see, I was going to say, what was the other thing, but I guess I just wanted to, you went on to point out this 0.4 and the line type and whatever. So I think that pretty well takes care of the questions I had on that.
The other thing, I listened in on a Sunday afternoon ROS 2 navigation meeting. A gentleman, first name Chaz, and another gentleman who said he mentioned Homebrew Robotics, like he's like the organizer or one of the sponsors or something they were on. So I just tried to listen in. It's not, I can't contribute on ROS 2, but it's just interesting to hear them, see where they're at and what they're doing too.
Yeah, that Chaz might be from somewhere in Texas, and I think they're the ones that do the they take radio control cars and they put ROS on those to make them drive around. And he is on frequently on the Homebrew Robotics meetings. So I think he's actually from somewhere else, if that's who I'm thinking of.
He did mention Texas. Cool. That's all I've got. So a little bit of progress, still frustratingly slow in getting it tuned right, but I think I'm making some progress.
You mentioned wheelbase in, I think, the TEB planner parameters. That's one thing I was thinking of that I know last time we were talking about this, and it was the question came up about, you know, like say the wheel diameters, and you know, the fact that there's a configuration file that feeds into a Python program that has wheel diameters, and then the URDF has wheel diameters, and then possibly in the TEB planner parameters, you know, there might be 3 different places that none of those are tied together. So you might have to track down, you know, each one of those. And something like wheelbase, for instance, if that's in the TEB planner, which I'm sure it has to be, because their process of converting rotational velocity into steering angle needs to have wheelbase. So the number in the TEB planner has to be right. The number in those 2 configuration files, that EM 305, whatever those were, if wheelbase shows up in those, then that has to be changed. And then in the URDF file, you know, if you pick the right vehicle model, you got to get the wheel, or the wheelbase possibly is in there. So again, you got this stuff spread out quite a ways. And someday we ought to figure out, how do you specify the number one spot and have it plug in everything? But right now it doesn't do that.
Do you mind, or do you have time to try to find that spreadsheet on my GitHub and pull it up and share? Because I'll show you what I did.
Yeah, it started down that path and I got confused and I reached over and accidentally hit a key on my keyboard and thought that blew everything away. But here, let me go back to find a link to your GitHub first. Okay, here's the Al Jones. Is it under ROS workspace, or should I just start at the top?
ROS 1, lawn tractor, something.
Here, I'll just start at the top and see what we got. Let's see, screen. How do I share the screen? Like this. Go like this. Get these out of the way. This bigger. Okay, so it says, can you see my screen at this point?
I can. So scroll down a little bit. There'll be a ROS 1. There you go. ROS 1 lawn tractor workspace.
Okay.
Project notes, I think.
Okay.
Vehicle dimensions is what we're looking for. There we go. Open up the ODS version. The Excel version was just to get it started. I think you have to download it.
Let's see here. Download. I don't know if that'll automatically open, but we'll see here.
The reason, thanks for doing this. The reason I wanted to have you open it up is to show you the 3 or 4 places where I found dimensions and the files, and that's a part of the, so let's see. If you scroll up to say row 30 or something, just to see where that starts.
Trying to make it bigger here, and I haven't. Now I got it locked up. Uh-oh. Why doesn't that work?
Those bolded names, like on row 43 and 48, those are the file names that I found dimension related items. And so like on row, I think that's 46, that vertice statement is computed based on the, again, that was a polygon type, but just a square box with 4 entries on that row. So what I was going to point out is you were mentioning the various files. The bolded names are the ones I found so far. If I'm missing something, yeah, then I've missed it, and I haven't verified that it's in those, what's in those files.
I'm still at a point here where I can't get it won't do anything, and I don't know why. Somehow I locked up my here. Let's do it the old-fashioned way. Control-Alt-Delete. Task Manager.
You're not maxed out.
How do I kill this? Just like this. In task. Okay, let me go back and see if I can open this. I'll try not to poke a lot of random keys this time when I start it. Let's see, how do I start this? Is it in my downloads directory? Downloads. Vehicle dimension ODS.
Just so you know, what I have on the screen is the GitHub page.
Yeah, I'm trying to, it decided it wants to recover that file after I killed it. So, okay, now let's see. Okay, now I can move it again. Now, if I wanted to zoom in on this, well, let me try this. Stop sharing. Share again. Here. And say share screen. Screen 2. And make that bigger. Ah, that didn't work. This one. Okay, so I got it back now. So maybe you should run me through any significant points there again that now I can see it. And but can you see that on the screen?
I can.
Okay. And
I'm trying to.
I tried to zoom, and that's how I locked everything up before. So if you know a convenient way to make the zoom in and get bigger, that might be handy. But otherwise, just tell me the fields again that were of significance now that we can see it.
So what you've got on the screen at the moment, I don't know if you could move to the left or not. Maybe I'd make that too small. No, that's cool. So those are the dimensions, pretty self-explanatory. I made it so that you put them in inches, and then it calculates the meters. I think I mean, we could go through that, but I'm not going to bore you with going through. There's some notes there on the right to try to make it more explanatory. I only have a GPS and IMU to worry about. So if you had other sensors and wanted to calculate, the position of those, you'd have to add to the spreadsheet for additional items. You were talking about diameter and wheel hub and things like that. Well, it's again reasonably self-explanatory which items that I've captured and how it impacts the statements below. So if you scroll down, yeah, right where you're at, this is the area where I begin to try to take the numbers that are above and actually calculate values. So I think, what is that, row 64? If you put your cursor there, you'll see the calculation or the algorithm. That's the Excel formula. I think you have to, well, I'm not sure, I can't see your screen to the point of, if you just go to that cell instead of highlighting the whole row, I think you'll see the formula.
Oh, the formula at the top. It says
so you can,
box size, character 34, D4, D5, D6, character 34.
yeah.
Is what,
so
is
then
what it says.
You can go back up and see the references, what's being used to create that statement. So back to what I was trying to point out earlier is those files that I reference that are bolded there are the ones where I found vehicle dimension references. So if you were like doing a checklist of, do I have all of the dimensions represented correctly, those are the files. If there's other files, then I'm screwing up because I've not included it here, which means I've not verified the dimensions are correct. But that origin, that footprint or vertice, there's one file where it calls it a footprint, another file where it calls for vertice, but both of them are looking for the dimensions of the vehicle. And that's where I want to change from four points and a vertice, which goes to the polygon type, to make it just a line type, which, as you just described, would be 2 points. But again, just starting at 0, 0 and going out the wheelbase. So that'll be an easy update. But I'll include it here and repost to GitHub when I get a chance.
Okay. Since we're in here, let's see, how do I get this stuff back now? No. Now I lost track of what I'm doing here. Oh, let me pull this over here. So the stuff that you were telling Terry was under, you said had your PID stuff. Is it under?
Go back to the workspace. It's not in this. If you're still in the ROS one, I don't have my embedded code in ROS one yet. Tractor laptop ROS workspace.
Tractor laptop ROS workspace. Okay. Under source or project support files.
Project support files. Embedded programs. And let's see, my PID is going to be, trying to make your screen bigger here. Why can't I get to the left?
Here, this one I probably can make bigger. We'll see. Ah, there we go.
So tractor. Would you mind opening up the tractor control 2022? Source. Main. And scroll down to see what the main loop looks like.
It's gonna be at the bottom.
Won't be all the way to the bottom. It'll be pretty close to the top. Yep. Start.
There's a compute PID. Is that the?
Yeah, that's the actual PID. And then it's not 8 lines, but pretty darn close.
Yeah. So I just want to get the path. So if Terry goes looking for it, you know, he can. In fact, here, I'll just copy that and paste that into here. Save me from having to do it later.
Those small must be global variables. I'm not seeing anything passed in just the input. Yeah. And then it returns out, input and output. And then if you just want to scroll up to the main loop, I think I have this going as fast as it can.
How come my search doesn't work now? Control, find, in. ACP. Well, I hate it when it does this. It says it's right there in front of me, but I can't see it. So let me try this again. Down. So it's in the title. And it says it's right there. Maybe it's buried out in. I assume you spelled Maine with no capital letters.
I assume so.
Hey, anyway. Why doesn't that work? Let me try it again. Maine. Huh. Let's try this. Maine. I can't find Maine with an open paren.
I put all my functions at the end, so the main loop would be above that. There.
Clear at the top. Handle incoming, blah, 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 get tractor, send that. Oh, is this Arduino code? If it is, then you're gonna have a loop.
Yes, it's
yeah, so main probably won't show up in here as a name. So I'll say loop timing variables, loop, void loop right there. You know, make it bigger again.
So you see my main loop is just 7 or 8 lines long, and it just calls each of those functions based on the interval that's set up. And so the steer interval, the steer interval will call the PID. Terry, if you're listening to this, so I don't remember what my steer interval timing was, but that's the speed at which my PID is firing.
Okay, this gets him into the file, and just that slight explanation probably will get him what he needs to know to dig through this.
The one point on this handle incoming messages, you might think, what's that all about? That's I have a LoRa radio that's off board, and so it's reading stuff from the LoRa radio as well. So in manual control, I'm telling it to go left or right. Ultimately, you can either do manual control or hand it off to the ROS controller, but I'm not doing that yet. It's all manual control. So that handle incoming messages is all about get the LoRa radio signal as fast as you can, which I think ultimately runs about 3 times a second. But anyway, it's all there. It's pretty open.
Speaking of the LoRa radio and remote control, I was thinking about trying to slow those messages down and see how slow I can get them and still have it be drivable. If I'd send out a something once a second, is it still going to drive well or not? Just the fewer messages I send out, probably, the happier it'll make anybody in the neighborhood if they're trying to run on the same system or whatever. So
you're absolutely right.
And the other thing is, then you just have to have a timing loop that says if you don't receive a message for X amount of time, like they put in all the ROS code, it's got to make sure you don't, for some reason you miss one, it doesn't just shut down when you don't want it to. But the fact that, rather than trying to send messages out as fast as I can, I just wanted to experiment with it someday and see, how slow can you send those out and still have it drivable. It's just that as you're driving and you move the joystick, it's going to take, up to a second for it to see that and start to turn. And I don't know how annoying that's going to be, but that's something I'm going to play with sometime.
Scroll up a second, if you don't mind. What is my steer vehicle interval?
Up under the defines.
It'll just be right. Yeah. I think there's a section for timing.
PID variables, steering variables.
There you go, loop timing variables.
So steer interval equals 50.
Yeah, so that's humping.
Well, it says 20 hertz is what it's at.
Right.
Because you have to convert those apparently. So okay. Now
So,
the inputs to that, is that taking like your speed or something? What was the PID doing at that point?
that means the PID will get fired at 20 hertz.
No, I mean, what are you putting into this PID? Is this your vehicle speed or is this something else that you're playing with?
Well, for steering, it's current angle versus target angle.
Oh yeah, this is
So
for steering. Okay.
So target angle is going to come from the radio. Assuming I'm under manual control, target angle is going to come from the radio control via LoRa, and the actual angle is going to come from the onboard steering angle sensor.
Okay. Your steering angle sensor, is that the magnetic one or is this your potentiometer that you're reading?
Since I changed, it's the analog 10-turn pot.
Okay.
Although I still have the magnetic sensor, since I changed to a 14-bit processor, the ADC in that is giving me, I don't know, 2,000 ticks or something. So I'm like, shoot, that'll be good enough, hopefully.
And the reason I asked that, I was just curious because if you're still using the magnetic sensor, I wondered if you're running that into your microcontroller or if you're running that back into ROS to get that angle.
For the moment, the magnetic sensors are on the left and right wheel for ticks from the wheel ticks, but for the steering angle, it's the analog 10-turn pot, which is going directly into this. It's a TTGO board that has LoRa embedded in it. You know, so there's a lot going on with that board.
Okay. My point was if you had a magnetic sensor on your steering, and if you're feeding that back into ROS to read it, then that means you'd have to make a message and send it back down to your microcontroller board, and all that adds timing issues by doing that. And so that's why I was wondering if you had the magnetic sensor, was it going directly into your microcontroller or to ROS? But since you're using the pot, you can just read that with the A to D, and you say read it, and bam, it should pop right up. So that gets around all these extra timing issues that I was just thinking about.
Yeah, but let me try to process that a little bit, because when I'm not in although this code is not written for ROS control, in ROS control, actual steering angle is going to be coming from that 10-turn pot, but target angle instead of come from the LoRa radio control is going to come from the ROS message. Yeah.
So your requested steering, it doesn't have to be at a high rate. You just simply say it's driving along and holding the position. You say, 2 seconds later, you say change it to a different steering, so that that's not an issue at that point. It's just the low level closed loop control that's keeping the steering where it's supposed to be. Has to read the pot and say, whatever we told it 2 minutes ago for an angle, that's what it's trying to control to. So that should work.
Cool. That's all work in front of me once I get the simulator to run a little bit better.
Okay, shut that off. So that's all I have for today. Do you have anything else?
I have a question for you, but I think you can turn recording off.
Okay. Stop recording.